Hi everyone, so today I'll be going through the recursion and financial modeling section of the 2018 Further Maths Exam 2. So question 4, Julie deposits some money into a savings account that will pay compound interest every month. The balance of Julie's account in dollars after n months can be modeled by the recurrence relation shown below. How many dollars does Julie initially invest? So you should know that in a recurrence relation, the V0 is the initial money, and this rule over here represents the savings account that pays compound interest every month. So from the recurrence relation, we know this is the initial, and this is the value after each year once you sub the value for the previous year in the equation. So initial value is V0, so therefore we know Julie's initial investment is $12,000 as stated from the recurrence relation. For BI, recurrence can be used to calculate the balance of the account after 1 month. Write down a calculation to show that the balance in the account after 1 month, V1, is $12,074.40. So to do this, we need to find basically V1. That's the value of V1 over here. We just need to show the calculation. So V1, according to the rule, would equal the previous value, which is V0. So 1.0062 according to the equation, times V0, which is the previous value, from V1. So V0 is 12,000 as we have given in the statement. So 12,000. So calculation to show the balance, and then if you put that on your calculator, that will give you $12,074.40. So put that in your calculator, and you get $12,074.40 as your answer. For BII, after how many months will the balance of Julie's account first exceed $12,300? So to do this question, we know that the initial value is 12,000. So we hit 12,000 on our calculator, hit enter. And then to find the next month, we just do that multiplied by our previous value, which was V0. And that would give us the first month, after the first month, the value of the and that would give us the value of Julie's savings account after 1 month. So multiply 1.00662. That gives us the value after 1 month, the value after 2 months, the value after 3 months. And after 4 months, we can see over here that the value has passed $12,300. So therefore, after 4 months. For C, a rule in the form of Vn equals A times Bn can be used to determine the balance of Julie's account after n months. Complete this rule for Julie's investment after n months by writing the appropriate numbers in the boxes provided below. So you should know that using an nth term relation has the V0 value over here and the R value over here. So you should write that for your rule as your nth term relation. So we know that V0 is 12,000, and we know that 12,000 would go over here according to our rule, and the value of R would go here, and according to our rule, we know that the value of R is 1.0062, so you write 1.0062 here, which follows the nth term relation rule. So therefore, that is your answer. CII, what would be the value of N if Julie wanted to determine the value of her investment after 3 years? So we know that the rule follows after n months. So it wouldn't be, the value of 3 years wouldn't be 3, because when n equals 3, that represents 3 months. So if you want 3 years, we need to do 3 times 12, because there are 12 months in each year. So if you do that, that gives you 36. So therefore, the value of n needs to be 36 if we want to find the value of the investment after 3 years. Question 5. After 3 years, Julie withdraws $14,000 from her account to purchase a car for her business. For tax purposes, she plans to depreciate the value of the car using the reducing balance method. The value of Julie's car in dollars after n years can be modeled by the recurrence relation shown below. For each of the first 3 years of reducing balance depreciation, the value of R is 0.85. What is the annual rate of depreciation in the value of the car during these 3 years? So you should know that the formula for the value of R is 1 minus little r, which is the rate of depreciation, on divided by n, which is the compounding periods, on 100. So if we use this formula, we can conclude that 0.85 equals 1 minus r, which we need to find the rate of depreciation. On n, we know that the value of Julie's car after in dollars after n years is multiplied by the recurrence relation, so that therefore n is 1 on 100. If you solve that on your calculator, you get r equals 15. So therefore the annual rate of depreciation in the value of the car is 15% per annum. 5b. For the next 5 years of reducing balance depreciation, the annual rate of depreciation in the value of the car is changed to 8.6%. What is the value of the car 8 years after it was purchased? Round your answer to the nearest cent. So to do this question, we need to, the way I do it is to find the nth term relation for the first 3 years, which I've found over here. So if you don't know how to get this equation, you would use the following rule over here. So you find the value of C0, which we have is 14,000, and the value of R, which we found to be 0.85, or it's given in the question over here, so 0.85. So you use this rule to find the value of the car after 3 years. So write C3, 14,000 times 0.85 to the power of 3. And if you do that, you should get 8597.75. So that's the value of the car after 3 years. Now we're going to determine the nth term relation, recurrence relation for the next 5 years. So right, next 5 years, and the rule would follow the same thing. Cn would equal, sorry, the value, this rule would follow the rule Cn equals this initial value, which is basically the initial value for the next 5 years, so 8597.75 times the value of R, which has changed. The new annual rate of depreciation is 8.6, so you do 1 minus 8.6 on 100 on your calculator, and you get 0.914. So 0.914 to the power of n. And in this case, we want to find the value of the car after 8 years. So the next 5 years is just to the power of 5. So C5.75 times 0.914 to the power of 5. If you did it on your calculator, you get 5484.23 to the nearest cent. So that is the value of the car after 8 years. Question 6. Julie has retired from work and has received a superannuation payment of $492,800. She has 2 options for investing her money. So option 1, she could invest for $492,800 into a perpetuity. She would receive $887.04 each fortnight for the rest of her life. At what annual percentage rate is the interest earned by this perpetuity? So you should know that the value of a perpetuity always stays the same, as shown by the graph over here. It always stays the same because you only take the interest. You only take the interest from the investment. So this money over here is the interest from the investment that she receives from the perpetuity. So this basically means that if you had to find the annual percentage interest rate, it would be R divided by N on 100 times the amount you invested, 492,800, which equals $887.04. That's the interest you're receiving each fortnight. So N is a compounding period. We know that she receives the interest. She receives $887.04 each fortnight. So therefore, the value of N is 26. And now we need to find the value of R. So if you solve that on your calculator, you will be able to find the annual percentage interest rate. So So if you solve that on the calculator, you'll get 4.68% per annum is your interest rate. Option 2, Julie could invest the $492,800 in an annuity instead of a perpetuity. The annuity earns interest at the rate of 4.32% per annum, compounding monthly. The balance of Julie's annuity at the end of the first year of the investment would be $480,242.25. What monthly payment in dollars would Julie receive? So to do this question, you need to use your finance solver. So we know that Julie invests $492,800 into the annuity. So that means the present value is negative 492,800 because we are investing money. So that's why the value is negative. The annuity earns interest at the rate of 4.32% per annum. So 4.32% per annum, compounding monthly. So monthly means we enter 12 over here. So the balance of annuities, the balance of Julie's annuity at the end of the first year of investment would be $480,242.25. So that means 480,242.25. We enter it as positive because this is money Julie would have at the end of the first year. So, and the balance of the annuity at the end of the first year is 12 for N because we know that the interest is compounding monthly. So 1 year would be 12 months. And then now we just have to find the monthly payments. If you enter that on your finance solver, you'll get 2800.00. So therefore the monthly payment would be $2,800 every month. How much interest would Julie's annuity earn in the second year of investment? Round your answer to the nearest cent. So the first step to find the interest, how much interest Julie's annuity would earn in the second year of investment, is to do the difference between the value of the second year minus the first year. So to find the value of the second year of the annuity, you'd sub N is 24, and to find the value of the first year, you'd sub N is 12, which is already over here. And we know that the value of the first year of the annuity is $480,242.25. So if you sub 24 and N, you'll get the value of the second year of the annuity. And if you sub that, and if you do that in your finance solver, you'll get 467,131.13 minus the value of the first year, which is, as we know over here, 480,242.25. So if you do that, you'll get $13,111.116. We won't round it for now. And then we want to find the interest in Julie's investment, how much interest Julie's annuity would in the second year. So the next step is to do the payments in that year minus the value, the difference between the second and third year. So the payments would be the amount of money paid and received, the amount of money Julie would have received in between the second and first year would have been 2,800 times 12. And if you do that, you'll get minus 13,111.116. And if you do that, that will be the calculation to find how much interest Julie's annuity earns in this between the second and first year. So if you do that on your calculator, you get 20488.89. So therefore $20,488.89 is how much interest Julie's annuity earns in the second year.